Okay, yes, questions? Go by your questions, so I have no agenda. Yes? Yeah. So you want me to give you some example where you got multiple preconditions and multiple postconditions? Just example. And no proof, right? Just example. Well, example could be, for example, okay. In your lab test, we talk about array container, right? Okay, how about that? If you say multiple, and no inheritance, right? Just a single class. Let's say this. Let's say maybe some interesting discussion could come from here. Oh, sorry, forgot. If I forgot, please remind me. Oh, I forgot to really get iPad. I forgot. My bad. Alrighty. File, new movie. That will be me. All right. There we go. Okay, and now I'll start a new iPad notes. All right, good. Okay, so let's see one example. Oh, maybe we can do it together. How about that? So we talk about precondition and postcondition, right? Let's say we do, let's say, remember array container, right? Let's say we have a class called array container. Let's make it maybe a little bit different. How about linked list container? Okay, linked list container. Okay, and then we have class end. Let's talk about different features. Let's say we do one command and one query. How about that? Okay, let's do a query first. Let's say we have a query to say, let's say array container. Let's say over here. First of all, we have an implementation. Let's not worry about the export status. Just assume something you will do later. Implementation will just be a linked list of what about integer. Okay, also make it easy. Okay, linked list of integer. And now let's say we got one query over here. Let's say find out the minimum. Okay, we can make it even simpler. What about simply just minimum? Okay, what's the minimum of this particular container? Okay, so now we talk about precondition and we talk about postcondition, right? The linked list should not be empty, I agree, because if the list is empty, there's no maximum, there's no minimum. I agree. Okay, that's good. So of course, whenever you do contract, like a pre or post condition or invariant, you can give a tag, right? You can say here, I can say non-empty container, and this one will be easy, and this will be, what about, yeah. In this case, let's say we, okay, yeah. Exactly, yeah, maybe just count. Count larger than 0. Let's assume count is just a feature. Let's assume, okay? Count larger than 0, right? That's one precondition. Let's do something that's interesting, okay? For some reason, I just want the container, whenever you ask for minimum, I want a container just to be sorted already. I want it to be, which means the implementation will be very easy. You just return the first elements. Okay, you see what I mean? Okay, just save. Okay, let's say sorted. Yeah, something like that. Sorted in, let's say, non-descending order. Yeah. Okay, just want to make sure it's fine. Yeah. Yeah, one moment. Let me just write it down first. Sorted in non-descending order, right? It's just tag. So now, since you asked the question, what should it be? What should it be? Huh? I lost you already. Okay. How do we write this precondition here to say that at the moment the linear container, the linked list container must be sorted? Because we know that every element in the container is an integer, right? We want it to be something like this. For example, it can be 1 followed by 1 followed by 2 and then 2 and then 3, right? That's one example. We want to say every time when you call this particular minimum query, we require that the container must be sorted already, let's say. Okay. Now, how do I specify that precondition? How do I do that? Okay, you can think about it. Yes, go ahead. Read it out, and I'll write it. Oh, yeah, of course. Let's assume, yes, you're right, because in the precondition, we cannot use any private feature, right? How about this? Let's relax that. So let's say this imp over here, just for the purpose of this particular example, let's say this one is somehow just public. It's not a very good design, but just for the purpose, okay? Let's say, yeah, across. Okay, well, write it down. So you're saying across from 1 to imp.count. Okay, let's assume it's start from 1. And then imp.count. Count minus 1? Good, I agree with you. Let's say put a parenthesis over here, okay? S, maybe I, maybe? Okay, S, I, okay? And then, so now for the across, do you want to use loop or sum? All, okay, very good. Okay, all. Okay, good. But to remember in the exam, make sure you say I.item, right? It's a minor, but you know. Okay, and then? Very good. I.item, sorry, I'm in another place, minus 1. And then that's be at the end of the across, right? Like that. Make sense to you? Say it again. What do you mean? Uh-huh. Yeah, basically, yeah, you can see that, yeah. Let's take the example I just put there as an example, right? The initial value for I over here would be just 1, right? The very first value for I would just be 1, in which case we are really comparing I.item and the I.item plus 1, right? We are basically considering this and make sure they are sorted, right? Less than or equal to. Are you okay or you are not good? Okay. You okay, right? Okay, very good. Okay, let's say the precondition. You got 2 preconditions over here. At the runtime, this will be checked first. If it is satisfied, which means the container is not empty, and it will check that they are sorted. Okay, now ensure, given this very strong precondition, which we decide to have, what should be the post condition over here? Okay. Okay, sure. So now, okay, so we can simply say, first of all, we can say correct. Let's say I say correct result 1, correct result 2, okay? Correct result 1 simply is derived from the fact that the array, the input array is simply just sorted. Okay, let's say derived from this. We know that it's going to be the first elements, okay? So what I would say is, let me use pink, or use green. So I would say result, which is going to be of type integer, is equal to imp at position 1. Okay? Now, let's do another post condition since you want multiple. So now, let's say I also want to make sure if I return the very first one, right? I will still want to make sure it is still the minimum, right? So now, how can I do that? So now, I will say correct result 2. Now, how can I specify such that result is really the minimum? Yes. Yeah, you can still just use a cross, right? Okay. Okay. Something like that, yes. Do you want to try? For you. Give me one moment. Okay, I'll write it down. Yes. Across, okay. Okay, you're saying imp.count minus 1. I'll write it down exactly what you say. Okay, if you want to fix it later, you can also fix it. minus 1, and then I don't mind. You can still use I because they're local to the loop, but we can use J, that's fine. And then, do you want to, what do you want to use? But remember, over here, we are trying to say result itself, right? We are talking about result is really the minimum among all the elements in the container. That's what we want to do. But you're saying, okay, I'll write down exactly what you say. Imp what? J.item? Just one. Okay? That's what you meant? Okay? Basically, what you're writing over here, you can see that imp1. Oh, I see what you mean. I see what you mean over here. Yes, this will work in the following sense, even though I don't think it's 100% clear. But I can first of all, let's see why it will work. We know that we actually put this correct result 2 follow after correct result 1. So which means at the runtime, if we can actually reach this point, that means result and imp1 are just the same. So when you write imp1 over here, it's as if you actually wrote result. It's as if. But somehow, if you didn't actually have this followed by that, you wouldn't have the guarantee. But for this particular one, it's fine. Okay, that's fine. Okay, but I would suggest it would be a little bit clearer if you simply say result less than or equal to imp j.item. Both are correct in this case, but I'm just saying if you simply put result here, because every time when you want to do a post condition for a query, you typically want to put the result over there. Yeah, just clearer. Okay, now let's do another one. Okay, so now this, yeah, question. Oh, yes. And then there's another thing, yeah, I forgot to mention. Yes, another thing, you can see that over here, you're putting imp.count minus 1. In that case, are you really checking all the elements in the container? Not really, right? Because this will be index 1, but this, you're basically checking imp.count. In this case, 1, 2, 3, 4, 5. Index.count is 5. 5 minus 1, you're only checking up to index 4. So that's not so right. So you should really only get rid of the minus 1 part. Okay? For example, maybe in the exam, I'll give you exactly what you just wrote over here. I'll simply ask you whether this post condition is appropriate or not. Your answer should be no, because this upper bound here will cause me to only check up to the second last index over here without the last one. And then you want to give me some counter example, something like that. Okay, so this one should be taken out. Okay, okay, let's do one more post condition, unless you have a question. Yes. Yeah. Exactly. That's exactly what I want to do. Yes. How about we do another post condition here? Let me put it here. Let's say nothing changed. Yeah, nothing changed basically simply means I want to make sure all the elements for the array remain the same. Okay, that's what I want to make sure. How can I be sure? Uh-huh. Yeah, you may do that, something like that. So now, if you do something like this, if you say across, right? Across what? That's cursor, that's fine. Okay, I'll say tell that, all right? Or equal. Actually, I can say equals, that's fine, yeah. Deep twin, okay. and then cursor the item. Beginning somewhere, yes. Okay, and then end over here, right? Okay, now any comments? Yes, you first, and then William. Okay, go. Yes. Okay, I like that. Okay, so now remember, okay, now for this part over here, I would suggest, without explaining to you right away, refer to this slides for common IFO error. There's a specific slide that we did in maybe lecture 2 or 3. I don't quite remember which one is covered. Please check it. Okay, but you're right. If without the parentheses, it may not just compile. Okay, good. Now, let's say we have this. Would that be okay? William, are you able to answer this? This might be something that we talk about during the office hour. If not, then everybody can answer. Guys, I can tell you the pink one I just specified is not quite right. Okay. Very good. Okay. Okay, for this one here, I also would like you to do some exercise. Okay, I'll let you know why it's not right. Okay. For example, let's say before I try to, let's say before and after. Let's say right in the beginning, let me just say, right in the beginning of the do, let's say we got do and end for this particular min, right? Let's say the following. Right in the beginning, let's say the array container looks like this. We will have 1, 1, and 2, 2, and 3. Agree? Let's say in the beginning. But somehow, the implementation over here is simply just wrong. How wrong is that? It's going to somehow to say 1, 1, 2, 2, 3, and then it will just add an element. Let's say. So it's wrong implementation. If the implementation is wrong, we will expect a postcondition violation. Okay? So now, what does that mean? That means over here, again, if you see old imp.deepTwin. So what's this? Old imp.deepTwin is going to be exactly over here. So this part, I think I meant to do here. So this part over here will be saved as old imp.deepTwin, right? It's going to point to this particular one, which is a completely independent structure. On the other hand, this guy over here is the new imp. So now, what's wrong here? If you try to execute this postcondition at the runtime, like an index out of bound exception, right? Because you can see that over here, we simply say from 1 until imp.count. Now, imp.count, rather than being 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 as expected, but now it got an extra element, which means index can go up to 6. In that case, when you go up to 6, in that case, this will give you some contra violation for the index. Okay? So now, how do we fix it? I'll hear some answer, but I'll rather this as an exercise. But just tell me your answer. I'll tell you whether that's right or wrong. Yep. You might do another postcondition to say the size is unchanged. Yes, you may. Yes, good. All right. So to really fix this, I'll just mention that quickly. So you can simply just do another postcondition to strengthen this to say not only the across should be the case, but also the size shouldn't change. All right. What do you mean if the position matter? What do you mean by that? Oh, the order of the in this case, yes, good question. Good question. So what you really want to know is something like this. So the new postcondition just suggested to say the count, the sizes of the imp doesn't actually change. Either you can put it here, or you can put it afterwards. Your question is, does it really matter? Good question. You guys thought, does it really matter? So now I want to say count somehow does not change, right? That's the kind of the postcondition I want to write. Okay? Now I got two possible places, either before the across or after the across. Okay? Does it really matter? But what's wrong if you put it in place number 2? What's wrong with that? Still okay. Yeah, exactly. You see the point? So if I put this particular new postcondition you suggested, let's say I put it in this point over here, that means you only get to check that after the original insufficient postcondition, right? That means you run into that index out of bound contract violation before you get to prevent that. So timing is really important because at the runtime we only check one postcondition after another in this kind of sequential order. So it does matter. Yes, it does. All right. Okay, it's quite a long discussion to your original question, but that's good, right? So now you see multiple precondition, you see multiple postcondition. Also, we also review quite a bit about O expression and also the complete postcondition, right? Stuff like that. Yeah, that's good, which we didn't talk about yesterday. Yeah, I think that's something you want to know very well. Yeah. You mean, okay, can you say that again? So if the class what? Sorry. Okay, so imp over here, because the element over here is simply just integer. Remember, integer is like an expanded type. So which means when you say equals, it's as if you say tilde is equal. So in this case, it wouldn't really matter, but you're right. Let's say, hypothetically, if I somehow change this to be something else, for example, if the class is simply just generic, if I put G over here, right, rather than just a particular type, in that case, over here, when you say equals, that would not be correct. So equals will only be comparing the references, right? In that case, you may just want to say tilde in this case. Okay. That's also fine. Yes, that's correct. That's correct. What you can do instead, well, depending on the question, right? Yes, you're right. Let's say we got G here, right? Let's say it's generic. You can get by saying maybe imp tilde imp, sorry, old imp dot deep twin. That's also fine, right? It's making sure the old array and the new array are the same. That's also fine. Yes. Yeah, I would say actually, depending on how I ask you about, right? If I simply say, now, give me a postcondition which will say nothing changed, the easiest way for you to write would be to say imp tilde equal old imp dot deep twin, right? However, if I say, let's say if I give you a postcondition that looks like this, in that case, you may have to figure out what's wrong, right? So different ways I can ask you. Good question. What if you're still asking me about how to implement this, right? Yes, good. True. It's a very good question. So basically the question is, what if we got imp over here to say linked list of some, for example, G, right? Okay. That means every element in the container is just another linked list. Okay, I would say it's kind of complicated, but let's see how we can do that. Maybe if I were to give you this question, this is what I would say. Let's assume the compare objects have been set already. So I can say, let's assume we already have an invariance in the class. That's something I will give to you, okay? We can say in the invariance simply say every element list in the linear container has been set for object comparison already. So what I can say is I can say across, right? Across imp as, I would say, list over here. It is the case that L dot item, which is of type linked list of G, right? I can say object comparison and end. That's what I can do. So I'm assuming that if this such invariant you can assume for every element list, so you can just use tell that. Yeah. Yeah. Yes. For the O expression, how do you know when to use current? I would say for the O expression, okay. For example, over here, you may actually want to look at, let me see if that is covering that particular slides, okay? Let me just go to that particular one. Okay, still have that. Let's see if that's covered. If not, then I will just do a new example. If you go to complete postcondition over there, let's see, I want to go to the O expression. So I want to go to, let's see, old expression. Yep, over here. That's good. Okay, let's have a look at this. Okay, that's something you should really try to review before the exam. Basically, over here we got different versions of the O expression, right? Over here, right? So now, specifically, what you're asking is something like this. Let's say, let's compare these two. Let's compare these two. So yellow, okay. One would be the O expression over here, right? One is applied to the accounts. The other one is applied to the currents, okay? So when to use the current version, the later version, depends on what you need, really, okay? So now think about what we are talking about here, okay? So now, because the current that we are having over here is really the bank, okay? And the accounts over here is of type, I think it is an array or list, I don't quite remember, array of maybe account, which is just one of the attributes for the bank, right? So you're talking about making the deep twin or making a copy for different objects, really. For the very first case, the old keyword applies to just the account array. So that means before the feature is executed, you will only try to cache the value for this particular array. That's the only one. On the other hand, over here, if you say old current, the current is like a this in Java. So that means the old current over here is going to make a copy for the current bank, which might contain other attributes, including array of your account, right? So it depends on what you specify. So back to your original question, when to use current? If you want to duplicate the entire current objects. But sometimes you may only want to duplicate the some attributes rather than the entire objects, right? Yeah. Good. Yeah, I would say this slide over here is really the key for this particular complete postcondition slides lecture. Right? This slide here, right? Remember this lecture here is about the complete postcondition. I would say that slide is the most critical one. Because in order to really write postcondition, you have to specify the old keyword together with deep twin. But to specify them right, you have to understand how the old keyword is interpreted by the compiler. Right? It's possible. For example, I might say, for example, let's say I give you, let's say between, well, this could be a good question, for example. I'm not saying it's in the exam, I'm just saying it could be a good question, right? So let's say I simply give you 1 and 2, okay? Now, I'll give you 1 and 2, and the question is as follows. I say, explain exactly the objects that are being cached before the feature is executed. Now, for this particular one, we'll say the array of account is cached. And for this case, the entire bank object, which includes the accounts, is cached. So that's a difference, right? So I don't quite get your remark. Say that again. Get at? Yeah. Correct. Yes, correct. So what you're saying is, let's say for this second one over here, you're saying that for this second one, you can, since I say old current, so I can say, for example, old current Okay, the O only applies to up to the current. But once you get a current, you can say maybe get at, for example. You're right, yes. On the other hand, if you say O accounts, you cannot say get at. It's just different context objects. Yeah. The whole array. Depends on, again, depends on how you write it, right? Okay, let me go a little bit deeper, okay? Okay, let's say we simply just do this second one, okay? All accounts, okay? Now, what I can do is, again, let's review this quickly. If I say old accounts, let's see what I wrote here. O accounts, okay, I and ID, okay? At position I dot ID. Okay, let's say that's version 1, okay? Let's see version 2. I say old accounts dot twin. It's a shallow copy. Dot ID. Okay, number 3. If I say old accounts different, right? At position I dot ID. Let's say got 3 versions over here, okay? They're different. We know that, right? So now let's really help you understand, okay? Let's see exactly what the picture looks like at the runtime. Let's say what we have is, let's say at the moment, let's say the accounts is simply just an array of account, of course. Let's say accounts is simply pointing to an array over here of accounts. Let's say we only got 2 accounts, let's say. And then one account object is like this. This is the other account objects. Okay, ACC for account. Let's say one is for Bill, the other one is for Steve. Let's say the balance for Bill is 200 and Steve is 100, right? Just for example. Let's say that's the accounts before the pre-states, okay? So now let's see exactly how these 3 will trigger the caching process, right? Okay, let me use different color, okay? Now for the first one, what exactly will be cached beforehand? Are we going to create a new array? Julian, go ahead first. Just reference copy to the same array, right? Very good. Okay. So under the hood, we got another. Let's say we got a like it's a hidden variable called O accounts, right? I'll just call it just old accounts, just in the variables, and then it's just going to point to this particular array, right? That's it. It's a reference copy. Okay, good. It is a reference copy. Now, what about the second one? Shallow copy, I agree. In the case of shallow copy, what do we do? Do we do more than reference copy, or we're pretty much the same? We do more than that, right? So what more do we do? Yes. So you're saying we're going to create new account objects or new, what exactly do I have to create? So what I heard, I'm not sure if I heard you correctly. You're saying we should make a duplicate of this object here and also make a duplicate of this object here. Is that what you meant? No. Okay, what did you mean? Okay, the array you meant. We're only doing a first level copy, right? Okay, I agree. So what you really want to say is that we want to create a new array like this. And then the new array, let's make it have a name. It's called O accounts twin. So I'll call that old accounts and then twin. Now, what about the accounts object for the red? What should it point to? Should it point to new accounts objects or reference copy, right? Only the first level is creating new object, but starting from the second level, only reference copy, right? That's shallow copy. So that means this is going to point to over here, and this is going to point to over here, right? Good. Now, last one. What about over here? The orange. It's a deep copy. Now, deep copy simply means we create new objects at every level recursively. Okay? There's no aliasing, exactly. There's no sharing, no aliasing, correct. They are completely independent, correct. Okay, let's draw that. So that means what we're going to have is something like this. Okay, I'll put it here. That means we duplicate the array, and the very first step for the deep copy is just the same as the shallow copy. But now we also got to duplicate the two account objects. Okay, the account object should be ACC, that would be bill, and then 200. And also the second account object will also be made a deep copy itself as well. And also we got Steve, and then 100, right? And then this is just going to be called over here, let's say old accounts deep twin. Right, you can see that basically what's really being cached, this is the case for the reference copy, where you only get this. And this is the shallow copy when you only get this, right? And this is the deep copy where you get deep twin, right? That's the difference. Of course, the third one is the most expensive one, but that's the only way to do it if the implementation try to make any changes beyond the first level, right? For example, if you have some malicious implementation, let's say a query, you just want to get a balance of somebody, but somehow you mistakenly modify Steve's account, let's say this. Let's say you have a feature, for example. Let's say I have a feature, let's call that get balance, for example. Get balance, and then it will take a name of the customer, let's say the clients. If I simply say I want to get the balance for bill, in this case, I would expect 200 to be returned. At the same time, no account should be modified, right? Let's say the implementation actually changes Steve's account from 100 to maybe 0. That's apparently wrong. But now, which version should we actually use in order to actually calculate, to specify the contracts? Should we do only a reference copy? Or should we do shallow copy? Would that be enough? Or should we do a deep copy in this case? Okay, now, I agree, it's always safe to say deep copy. It's always enough, right? So it's like almost saying nothing, right? But now, what I want to ask you about is, let's say I try to make a change mistakenly at the second level over here. Why would this one here not be strong enough? I'll write it down, exactly. Let's say this is the postcondition I want to do. Let's say this is the postcondition. I would say old accounts dot twin. For example, let's just say Steve, okay, is at position 2. The same as old, okay, actually not old, sorry. And then accounts at position 2. Okay, so this is the postcondition that simply uses the shallow copy, right? And now remember, in the implementation, let me just make it complete. Let's say in the implementation here, I say that result, of course, this is going to return, let's say balance is integer, make it simple. Let's say result is simply assigned to, let's say we want to get Steve, we want to get Bill. So that should be accounts at position 1 dot balance. So this line is the correct implementation. Let's say we do something that's wrong. We can also say at the same time, ACC at position 2 is assigned to, let's say 0. So this is really the part that's wrong. And we agree we should really expect some postcondition violation from this wrong implementation, right? Are we going to get a postcondition violation though? No, right? Okay, let's see why. If you look at that, so that's why you really have to understand why how you write the old expression is going to affect the way the values will be cached. Let's say in this case over here, when you say all accounts.twin, it's really talking about this particular shallow copy over here, right? That's a shallow copy we'll talk about. And it's all accounts twin at position 2. At position 2 is talking about this object over here. You're saying that that object there is the same as accounts at position 2. Accounts is over here. At position 2 is referring to the same objects. You're saying the same object is equal to itself is trivially true, right? So now how can we fix this? Deep twin. Good. Exactly. So the way to fix this is by saying something like, well, rather than twin, it should be deep twin. Yeah. Yeah, I like the question. That's pretty much like exactly what you have to know from the complete postcondition lecture, right? Yes. Proving, yes, we can go there. But are we okay with this about deep twin, twin, and reference copy? Good. Okay. Yes. Sure. The reason that, okay. Because, okay, the general principle is if you only want to do shallow copy like over here, right? You can only catch the error where the implementation is trying to do only the first level change. But if they try to do any second level change, for example, they try to change the balance mistakenly, that's actually beyond the first level. So in that case, the shallow copy is not able to tell the difference. Reason being, if you look at that, old accounts twin at position 2 is referring to, position 2 is referring to this object here, right? At the same time, accounts at position 2, accounts is over here, at position 2, again, is second level. So it's also referring to the same object. That's what shallow copy does. Correct. 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 Yeah. The deep copy is always complete to use, always. But what I really like is for you to know when to use which. Maybe I'll simply give you something like this. For example, I will give you something to start with, maybe say this particular postcondition over here, and then I'll give you some wrong interpretation. I'll ask you to explain, would this postcondition here, where I use a shallow copy, would it be strong enough to catch the error, right? The answer is no, but I gotta explain how it is not going to catch the error, right? And then the fix will be change this to deep twin, right? Okay, yes, any about this? I don't quite get your question. Say that again.
We just need to contain a postcondition chat for the items to ensure the result correctly.
You're talking about over here, right? Yes, true. Yes, correct. So you got to use deep twin. Yes, deep twin is always safe to use, but in some cases, if you can make certain assumption that the implementation is going to be this wrong, then you can use shallow copy sometimes. Okay, good. Yes. Yeah. Yes. Oh, yes, good point. Yes. So what William just said was, over here, if you know, again, it depends on the cases, right? Somehow I make the case very simplified. So each element is simply just an integer. It's not really like an object structure. In which case, you don't need a deep twin, because even when you say reference copy, it's just going to create an integer, right? But the general case would be if you just have G. In that case, of course, we go back to the general scenario. Yes. Yes, for expanded objects, so there's no reference to it. So whenever you talk about this, for example, basically something like this. So let's say you have, class A over here, and then, okay, you have something over here. Let's say any attributes, or even of some reference type or expanded type. So now let's say if I say A. I would say RA for reference A of type A. EA for expanded A. I can say expanded A, right? So I got two cases, right? So that means at the runtime, if you say RA, you're really talking about RA is simply just an address that store the address of some objects in the memory of type A, right? On the other hand, when you say EA, there's no address over here. You're just referring to just the object itself. There's no address, so there's no aliasing. Okay, to make it a little bit more interesting, if I say EA1 and then EA2, okay, and RA1 and RA2. Let's say RA1 is pointing to this particular object and EA1 is referring to this object here, right? Okay, now, if I say something like this, if I say RA2 is assigned to RA1, what I'm doing is I'm only copying the address that is stored in RA1 into RA2. I'm not creating any new objects, right? That means RA2 is just going to point to the same objects over here, just aliasing. On the other hand, if I say EA2 is assigned to EA1, now the assignments over here means something a little bit different, right? Because there's no address for expanded type. So what I'm doing is I simply say I'm just create a new object of type A, and then for every attribute over here, I'm going to copy verbatim, okay, recursively, and then that'll be EA2. So there's no aliasing, okay? Yeah. Make sense? Good. Correct. So expanded type, remember one use case would be when we talk about the singleton pattern, right? We said for a little bit simpler writing in your code, you can say for the expanded, for example, let's say model access, you can just declare that as an expanded class. So that means when you declare the expanded model access as the local variable, you don't have to explicitly create that. It will just be created, right? Yeah. Good. Any more questions about this? Okay, you asked about correctness. Which part exactly you want to go over? You mean given some precondition, given some postcondition, how can you prove it, right? WP rule. Okay, how about this? Remember I talked about the swap program that we talked about before, right? I remember one of your colleagues actually gave us some answer, how to do a swap. Let me give you my answer. Let's try to prove it all together. How about? Okay. Now, okay, that will review the whole example. Okay. Okay. So what I would do, let's give you. I'm asking the following: is this program correct? Okay, I'll give you the program. Okay. Now let's do some IFO program over here. Let's say we got X of type integer, Y of type also integer, and then I have a swap program, which is a command, okay? And then for the require, I would say X larger than Y. And also for do, okay, I'll do the following. Let's say X is assigned to X plus Y, okay? And Y is assigned to X minus Y, and X is assigned to X minus Y, I presume. Okay. Ensure X equals OY. Y is old X. Okay, you know what? Let me just make it a little bit simpler. Okay, otherwise it's too complicated for the illustration. But you can expand it for sure, right? Yeah. Okay, let me just make it a little bit easier for you. Okay, so also easier for me. Okay, like that. And okay, stare at the program for a moment and just get some intuition whether that should be correct or not. Oops. If I can just get a square from here, that'll be great. Good. Okay, that's a program. IFO program. Do you think that's correct? You think so? Okay. Our claim, well, we'll prove it, okay? How about we try one example together? Just try example, right? It's very informal. That's not something you're supposed to do in the exam. Okay, let's say this. For example, let's say x, to start with, x is 10 and y is 5, for example, okay? And now, x, after this point, x will be assigned to 15, good. And now, after this point, what will be y? Will be 15 over here minus 5, 10. So y now got the ox value, right? And now let's do another one. What about here? After this, x will be assigned to x, which we haven't touched yet. X will still be 15. We have 15 minus the latest value for y. That'll give us 5. Okay, it seems like we have done the swap. Agree? Okay, that's a very informal proof, right? By the way, this is an interview question, as I said before. The question is, do a swap without using an intermediate variable. Okay. Right. Now, let's prove it, right? As you said. For this one, you're going to use assignment and sequential composition. There's no if statement. You can try to expand this, expand that yourself. Okay, now we got an informal proof. Let me just undo. So now we're somehow informally sure that the program is correct. But how do we prove it? How do we prove it? So now, what should be the first step? Okay, first step, write a Hort triple, right? Now, how do we write a Hort triple? Okay, step number 1. So let's write a Hort triple. Basically, you want to formulate the program as a Hort triple. Okay, how should it look like? Curly brackets, right? Okay, now what should be the precondition for that? True, right? Because there's no precondition as if it's true. Okay, I'll put true here. And then the program part will just be the 3 assignments, right? Okay, I'll just write it down. X is assigned to x plus y, followed by y is assigned to x minus y, followed by x is assigned to x minus y. Okay, what about the postcondition? Yeah, over here, right? These two, right? When you got 2 postconditions, one followed by the other, it's as if you put a conjunction, right? This must be true, and the other one. Okay, I would say x is equal to oy. I would say y is 0. Okay, O to y, right? That's what we said before you can use it. And also, y is equal to x0. So y0 is like an old y, and x0 is like an old x. Okay? That's the first step. And after the first step, basically we know that we want to prove that this particular Hort triple is it can be proved as true. How do we prove that the Hort triple is true? What's the next step? Yes. Okay, very good. I agree with you. So that was step number 2. Okay. Now step number 2. So help me out. How do I? Yeah. Yep. Oh yeah, so in this case, what should be the WP takes 2 arguments, right? What should be the first argument for WP? The body, right? Okay, so x is assigned to x plus y, followed by y is assigned to x minus y, followed by x is assigned to x minus y. And then the second argument should be that predicate, right? So x equals y0, y equals x0. Okay, just enough space. Okay, again, 2 arguments, right? The first one is the interpretation over here. And the second one is the postcondition we'd like to establish. By the way, is there any need to prove termination? Have you thought about it, right? Remember we talked about proving termination. How do we prove termination for a loop? You somehow have to argue about the variance, right? To say the variance always stay non-negative, And also between each iteration, it should be strictly decrease the value for the variance. But now in this case, there's no loop. That's why there's no way it can run forever. You only have to prove about termination if there's a loop. When you only got simple like a sequential composition assignments or any like a if statements, if you only got a combination of these three, you don't have to worry about termination, it's guaranteed. Sure. If you only got a program where you only allowed to write if statements, assignments, and sequential composition without any loop, it's guaranteed your program will terminate always. In that case, you don't have to bother, right? It's quite intuitive. I'm just stating that, right? You only have to worry about termination when you got a loop. Okay. Now, how do we calculate that, right? Well, it's kind of similar to what we did in the class. Similar. Okay, I will just give you some overview, and then you can complete the rest, right? It's not really difficult. I just want to show you the format, basically, okay? You can see that we got one here, we got one here, one here. Oh, you know what? I highlighted wrongly. Okay, my bad. Okay, yes. I think what I meant to highlight was like this. And then followed by this. Okay, I think that's what I meant. Good. So now you can see that we got two sequential compositions over here. That means we have to apply the sequential rule 2 times, right? So now what we can do is, let's try to divide them in this way, okay? Let's say this is the very first phase, and that's the remaining part. Agree? Okay, so now we're going to say is equal to WP rule for sequential composition, right? Let's apply the first one. So that will be WP, okay, I'll still put it here. So WP, so now the idea is for the first phase to establish a postcondition that will be strong enough for the remaining phase to execute and terminate in a state that will establish the eventual postcondition. Okay, let me write it down, and then I'll repeat. So this is going to end up with a state that is just going to be, again, the weakest precondition for the remaining part, which is y is assigned to x minus y, followed by x is assigned to x minus y. And then that one there, you can say, oh, and that one there is going to establish the eventual postcondition, which is x is assigned to, x equals y0 and y equals x0. Okay? Okay, I'm going to close the brackets over here and also close another one here. Okay, is that good? Now, how do we go on? You got another sequential composition over here, right? How do we handle that? Basically, you want to make sure by executing this, you will end up in a state that'll be enough for this remaining part to actually execute and terminate so that the eventual postcondition will be established, right? Pretty much like what we said in the class, okay? Let's do it. So that will be equal to, let me use green over here. That will be equal to, and then we say WP rule for, again, semicolon over here. So I'll do that. So WP, x is assigned to x plus y. That's the first phase. And after the first phase, we want to establish the weakest precondition for the second phase. Okay, and then upon the termination for the second phase, we want to make sure it is enough for the third phase. Okay, actually, for the third phase, to actually execute for the third phase, which is x assigned to x minus y, for the third phase to execute and then end up in a state that's an eventual postcondition, right? Okay, I'll put it here. That's x equals y0 and y equals x0. Okay, so now we got green, and we got pink, and we got this, dark. Okay, so far so good? The pattern is really the same as the example we did in the class. Now, what should you do to continue? The rule for assignment, right? How many times? 3 times, right? Because you can see that over here we got, for the first time you can get rid of the green part, the second time you can get rid of the pink part, and the third time you can get rid of this part here, right? After that, you'll get it. Okay, how about that part? I leave an exercise for you. Okay, now, after that, whatever WP you get from the second step, okay, whatever you get from the second step, you will want to argue that the original precondition over here, which is true, does that imply whatever you get from the second step? That's something you want to argue. Okay? Since we claim that this particular program is actually correct, that means the weakest precondition here, I suspect, it will just be true. You can verify that for me. Okay? Okay, good. That means it doesn't matter what x and y is. If you execute these 3 lines of code, you will always swap x and y. Okay? Okay, hopefully that answers your questions, I guess. Okay, at least you should, I think what's really important is you should know the flow of the pattern, right? And let me say one more thing. Okay, it's really important. So when you actually answer a question like this on the exam, you want to make sure you actually was, if I start with a line like this, right? If you can go to the next line, you must explain the reason. That's really important. Okay, as I said in the last class for the exam tips. Okay? I can repeat, yes. So now, when you calculate the WP, right, usually you just go from one WP expression to another WP expression. When you go from one to another, you must explain why it is the case. And the reason can be maybe WP rule for sequential composition. It can be WP rule for alternation or for assignments, right? You gotta explain, you gotta justify every step. Okay? Yes? Okay? Which one is x0? Okay, I see what you mean. So now, when we talk about x0 over here, okay, when you look at the old x over here, right? When we say old x, we really mean the very first x value before the feature is executed, right? It's right before the due. That's basically x0, old x. But any x value in between, we don't call that x0, so don't get confused. You only call the very initial value over here that's public to the clients because you can refer to x0 over here. So that's the very first value, right? But I would say over here you don't have to worry too much because what you got to do is you want to make sure when you do the replacement, when you say x is replaced by x minus y, you don't actually replace the x0 over here by x minus y. You got to replace only this x over here by x minus y. Because this x0 over here referred to the very first x value that you don't want to touch. Okay? Yeah. It's a good question. Yeah. Okay, any question about this particular example before I take the next one? Okay. Okay, we just passed the first hour, but we still have some time. You mean the step number 3? You mean over here? Exactly, you want to do a substitution. Yeah, you got to do one by one. I would say you may just need another 3 lines to say the first line, you want to apply the assignment rule for this particular one. You're going to replace every occurrence of x by x minus y. In this particular postcondition, right? You do that first. Whatever you get from there, you're going to apply the second rule for assignments over here, where you're going to do the replacement for every occurrence of y by x minus y. And then you will end up with something. And for that thing, you have to make sure replace every occurrence of x by x plus y. And then you get a Boolean expression. Okay? That makes sense to you? Good. Unless you want to do it together. Shall we do it together? How about we do it together quickly? Okay, let's try. So now let me just get rid of this, okay? Let me just do in a way that's kind of easier for you to follow, but we can say WP rule for assignments. Okay, so now how do we replace every occurrence of x by x minus y? So what do we get? So x will be x minus y equals y0. And y doesn't change, so y would be equal to x0. Agree? That's the first one, right? And then after this, of course, this would be, of course, the WP over here for the second phase, I gotta put it here. Okay, I'll just do one for you. You can do the rest. Okay. Okay, I'll put it here so that'll be easier for us. Okay. So let me get rid of this. Okay. So now what I have is, it's gonna be WP. Actually, I need a little bit more space. It's going to be WP, y is assigned to x minus y, and that one should establish this particular one, right? And then it's going to be for the first one, WP, x is assigned to x plus y, and then this whole thing over here, right? Basically, going from here to here, we have reduced 3 WP into only 2 WP because this one here is gone, right? Okay, you can do the other two. Okay. You really want to get used to this kind of substitution, right? So don't want to spoil you too much. Okay, any question about this topic here? Yes. Oh, you mean that is this everything you had to study? Oh, no, I would say pretty much. Yeah, because you can see over here, we just follow through the steps you have to do in order to prove the correctness of some given program. I think the only thing I haven't really talked about over here, number one, looping variance, and number two, loop variance, and also how you can prove the 5 different conditions over there. Yes, correct. Yes, that'll be the rest. Yes, but the idea is really there. Yeah. No problem. And we may want to also go over very quickly the examples where I show you the version of the looping variance and variant that are wrong. You want to know how they can go wrong. Okay, you want to be able to explain. Okay, that's also very important. Yeah. Yeah. Yes.
So the correctness slide,
Yeah.
you give us 2 primitives.
Yes. Yes. Yes, I'll go there. Yes. Okay, what I will do is I will comment correctness. The second one? Yes. Oh. Yes. Basically, okay, here's the rule. Okay. So every time, let's say this, if I have, let's say AI, let's say I start with this, okay? When you first state the weakest precondition over here, you simply say, I want to prove that after this particular implementation, I have a position I larger than 0, right? So we know that I over here has to be guaranteed to be a valid index. Otherwise, you get into the index out of bound contra violation, right? So that's why we have to, whenever you see this, you have to make sure you just extend the ending postcondition you want to establish. You want to make sure after S over here, in order to prevent from any contra violation about index out of bound from happening, you want to make sure not only that it should be AI larger than 0, but also the I itself is also valid. That's what I meant. Yeah. So again, and whenever you see any AI, something like this in the postcondition, you want to just have something extra to make sure I is also valid. Okay. Yeah. Guys, any more questions? Yeah, Actually, I'm happy because what we covered today is pretty much different from yesterday. So when you review the videos, you will see many aspects. Yeah. Yes?
We covered
The template, no, we didn't. You want to go over that quickly?
Yeah.
Sure, we may. Let me find out the slides for that. You're basically asking the state pattern, but I want to go to the one that you talk about. Okay? So now what I want to show you is something here. Okay, I think let's look at the architecture very quickly, okay? So that's the architecture for the state pattern. Let's review that very quickly. So what we have is, so we have application, the clients, and the supplier is simply just single states, right? The state itself is deferred, okay? And then we got so many different descendant classes over here. Each one of them represents a state, right? Each one of them is also effective. Okay, so far so good? Good. Now, I want you to look at the features in the state class over here, right? Especially you can see that, let me just highlight them over here. You can see that, for example, read is more like, for a particular state, what should be the input to be entered by the user. For example, in the kind of initial states, the read can be defined as follows. Maybe we want to take the student, the user's credential. What's your login? What's your password? And what's your name? Etc. Right? On the other hand, maybe the read feature for maybe flight inquiry, the read will be defined differently, because maybe in the flight inquiry states, you may want to say which do you want the morning flight and what's the origin, what's the destination, right? You'll be defined differently. So that means over here, you can see the read over here is going to be different from the read over here from different states. That is why we simply say it's deferred. At the level of a general state, we simply don't know how to implement the read feature. We can only know when we get to the specific level for the descendants to implement them differently. So far so good? Good, okay? And similarly for all the display, correct, process, and message, the same for all of them. Okay, now, if you see that for one of the features over here at the state level, which is called execute, itself is not deferred, right? Notice that, it's plus, okay? Whereas all the others, they're simply deferred. These features, they were deferred simply because we cannot decide how to implement them at the state level. We can only decide at the descending class level. However, for the execute feature, we can already know how to define that at the state level. The reason is as follows. The way you try to execute a particular state, you have to follow a fixed pattern of workflow. The pattern will be something like this. Okay, let's see that. Okay, the pattern. So that's a template pattern basically, right? So that means at the deferred class called state over here, we have a feature called execute. It's not deferred, right? Whereas all the others, for example, read is deferred, answer is deferred, sorry, not answer. Display is deferred, correct is deferred, process is deferred, and message is also deferred, right? But now, the execute is not deferred. We do have some implementation there, okay? Now, the interesting thing is, you can see that over here, it calls the display, also it calls the read, it calls the message, it calls the correct, right? So that's where the template comes from, which means for every single state, doesn't matter which one you're talking about, the way you execute each state is going to follow just the same pattern over here, just the same. Okay? You always do to say you do a loop until all the inputs from the user are good to go, right? And then you always do display something there, and then read some input from the user. And then you also do some validation for the inputs, and also you display some error message, right, at the end. Also, you do some process of the input, etc. Right? The pattern for the workflow is the same for every descendant class over here, the same. So that's why we don't have the duplicates. So that's why we only have to define the execute at this level over here. We don't have to say execute over here, and then duplicate the pattern again for execute. We don't have to. Okay, that's not the way to go. That's what the template pattern is. Let's go a little bit further. Let's say this. if I try the following, let's say, let me just use the two initial example I just did. Okay, let's say we got initial and we got flight inquiry. Okay, so now let's consider the following code. Okay, I'll put it here. Let's say this. If I have S of type states, I would say creates initial S dot make, for example, and then I can say S dot execute, all right? And then I would say creates flight inquiry. S dot make. And then I can say S dot execute. Okay? Let's see how the template pattern actually works. Now, at the runtime, we know that S is just going to point to some state objects, right? Now, after this particular line, we know that dynamic type for S will just be initial. That means S is now going to point to some initial objects, right? And we know that for initial, if you look at the diagram again, initial itself is actually going to define all the read, display, process, and message over here, right? All the features that used to be deferred in the state class, okay? So what we can say over here is, you can say over here we have display. For example, you also got message. You know, these are just plus, okay? Now, when we say S.execute over here, where is the definition, where is execute defined? In the state, right? If you look at that, it's exactly over here in the state class. Oh, that's execute. Okay, in the state class. Now, if you look at that, it's going to execute this particular loop over here. Now, specifically, let's say, if we get to this particular display over here, which version of display is this defined? It's the initial, right? Because over here, you can see that this execute over here, we know that part of it is actually going to call S.display, part of it, in turn. Right? It's kind of the part of the pattern, the template. Now, S.display, depending on, because of dynamic binding, which version of display will be called depends on what's the dynamic type for S. In this case, well, it's initial, so we call this particular version of display. Okay, good? Now, let's go further. Let's say we do another line over here. We say creates flight inquiry S.make. So what does that do? That means we're creating a new object over here, flight inquiry, and then we are making some reassignments over here, pointing to here. And that itself is just another descendant class of the state class, right? And over here, if I simply say, it also has its own version of the display and also its own version of the message. Great? Okay, now, if I now again try to execute the same line over here, same question for you. Where is the definition of execute over here defined? The same version, right? The same template, basically. Okay, again, it's going to be the same execute that we are trying to execute here, which is defined over here with a pattern. And part of it is going to be display. Okay, if we go back here, and then what we do is, part of it is to say S.display. Now, which version of display is it? All right, good. You can see the same template for all the descending classes of the state. However, each component of the template is going to exploit dynamic binding to see which version of the display, message, process to call. Right? That's the beauty about template pattern. Make sense to you? All right, good. Yeah, that's good. Oh, I see what you mean. So you're asking basically if you have, let me go back to the architecture over here. You're asking, what if I just don't have the execute over here? It will still be a state pattern. Basically, state pattern over here is simply just have a state, deferred, and also got different descending classes, right? Also, you got a polymorphic collection of states at the runtime, right? But execute over here just nice to have because you can avoid duplicates of code for execute in every of the descendant classes. Right? Yeah. I think, of course, I wouldn't really ask you to write a code for the other two versions. If I, for example, let's say the first one is just using goto, right? If I give you a fragment of code of the goto in the paper, I would say consider the following design, where I simply use, let's say, I'll make it more concrete for you. That could be on the exam for sure. If I got something like this, okay, let me just go back there. If I simply got something like this, for example, I give you this, I say, consider the following design for a flight reservation system. Now, criticize the design, right? In which case, you have to know how to criticize it, right? About how centralized it is to the particular application you're using. It's not general, right? For all the criticism that we talk about in the class. Or I might also give to you maybe the code for the second design, which is more like a top-down hierarchical design, where the state information is passed around between different levels, in which case you also have to tell me why it is bad, right? In particular, I think there was one feature which we said is going to violate the single choice principle, right, over here. Because let's say for display, right, over here you're passing the current state information over here, but now the current states, you don't know which, it may have many possibilities. It can be initial, can be flight inquiry, can be many others. So that means every time when you want to do the display, or you want to do re-answer, re-choice, correct, process, and message, any one of them, they will take just S, the current state, as the input. In that case, you have to repeat the same exhaustive check always. Again, the very important insight you want to get into the state pattern is, how do we move from the second design to the third design? Here's how we move it. In the second design, I might say display, and then I would say, for example, number 2. Let's say number 2 really represents the initial. Let's say flight inquiry, for example. Inquiry. It's just a constant, right? That's the second design. So every time you want to do display, you want to pass us current states. And for the third design, which is OO, the state pattern, what we want to do is, rather than having this kind of explicit checks, we delegate that to dynamic binding at the runtime. How do we do that? What we do is we'll simply say S of type states. Okay? And then we'll say create flight inquiry S.make. And then we simply say S.display. Right? You see over here versus this. You can see the display over here no longer takes any input. But now, it really depends on what's the dynamic type for the current objects over here. Right? If the dynamic type is actually flight inquiry, the runtime is going to make sure the correct version is called for you. So you don't have to do the explicit checks for yourself. Okay? That's, again, the very much insight you want to get from the state pattern. Yeah, it's a very quick review, of course. You know, if you want to see the detail, refer to the lecture recording for the state pattern. Right? Okay, any more questions? Yeah. Event-driven?
Visitor versus observer. Now, the complexity, which is like the big O was briefly mentioned, are we expected to do computation, like how to compute?
The question is, okay, you're a little bit bothered by this particular big O I put, right? That's okay, you know. But you know, since you learned that in 2030 and 2011, right? Doesn't mean if you finish the course, you get it away, right? You want to keep that. Okay, let me just go there and tell you what you should know. Basically, you're asking the following. Okay, you're talking about observer, which I'll just go to the slides. Okay, I think there's one slide where I talk about over here, right? You're basically saying this. Okay, that's the case where you got multiple subjects and multiple observers, right? At the runtime, the links can be as complicated as n multiplied by n. You got n subjects and n observers, right? And now, the reason we want to move from observer to event-driven design, in the case you got very large m and n, is you can see now, rather than having n and n, we got only n plus n. Okay? Now, as far as this course is concerned, you just have to understand how this particular scenario, why you move from m multiplied by n to n plus n. But we wouldn't, yeah, we wouldn't really give you a fraction of Eiffel code and ask you, what's the big O for that? There's no point, right? Yeah, I cannot do that actually. Yeah. I think that this one here is not really about runtime. It's mainly about the complexity for the links. I think for the other one, since I didn't really mention, so you don't have to worry. Yeah, to be honest, you don't have to worry. Okay, anything else? Yeah. Yes. No, you don't have to. For the math models, so basically in the exam, if we want you to implement anything, you will be given the feature you need. Yeah. Even if sometimes if we forgot to give you the critical feature, you can just assume. You can say, I assume we got this feature here. Yeah. Good. Okay, guys, any more questions?
I have been going through the previous lecture notes about the bomb diagram. We expected to have this power control.
Yes, correct. Yeah.
But the implementation of like arrows and I could not find the implementation which is not.
Sure. So basically, I didn't really have, for now, I don't have a slides yet to actually tell you this is what you had to draw, this is what you had to draw. We have been doing the learning by examples, right? We have studied a bond diagram for basically every pattern that we talk about so far. So I would say just refer to them. They show you how you can draw the client supplier, how you can draw the inheritance, how you can draw label for the client supplier, right? Yeah, I think that would be enough. Yeah, you wouldn't be asked to draw something that's more complicated than that. You know, you wouldn't be. Yeah. Yes, I would say try to be as complete as possible. Every time when you draw a class, you want to denote if that's deferred or effective. Also, if there's a feature, you want to say it's either deferred or effective or redefined, right? Like how we reviewed in the last class. Yeah. You wouldn't be asked to draw so many features anyway. So in the exam, it's, yeah. Yes. Subcontracting, briefly speaking, subcontracting simply means you have a subclass, and how should a contract be designed, right? So, okay, before we talk about inheritance, we say for each single class, you have class invariants, and for every feature, you have precondition and postcondition, right? So now we're asking, if you have inheritance, which means you have a subclass, is the subclass going to inherit all the contracts from its parent class? The answer is yes. They're going to accumulate the contracts, but the way you accumulate the precondition and the way you accumulate the postcondition is different. That's why we gave you the lectures on how they should be understood, right? Subcontracting basically just means what does contract really mean in the context of inheritance. Yeah. Specifically, we want to make sure the precondition in the subclass should require no more than the precondition in the superclass, right? And also the postcondition in the subclass should ensure no less than the postcondition in the superclass, right? That's something we have been talking about. Yeah, exactly. So you want to make sure when you actually try to call a particular feature, because all the client can expect is from a static type. You want to make sure when the dynamic type is being actually called a feature, it's not going to shock the clients, right? Yeah, exactly. Yeah. Okay, guys, anything else? We still got about 20 minutes, but you don't have to. Yes. We did. Multiple inherit. We mentioned that in the composite pattern, briefly. I would say that's all you have to know. Yeah. For composite pattern, yes. Yeah. Okay, guys, yes? Oh yeah, we'll be very clear. So we'll be clear to say maybe for the pre and post condition, maybe in this case you may have to write in English, maybe, or you had to write in valid Eiffel syntax. Yeah, we'll be very clear. Yeah, but I would say the style would be a little bit quite different from the midterm. Yeah. So the style, yeah, will be quite different, which means we have no multiple choice, and I would say each question should be quite straightforward, in the sense that you know what you're asked to do. Yeah. But huh? Well, so I don't quite get. Yes, but you rather be the question be very clear, right? You don't have to spend so much time figuring out what's being asked, right? Yeah. Yeah. Correct. You might be given, for example, I might give you a tag to say this is the post-condition tag. Now write it down in Eiffel syntax, right? Well, it could be that I give you a post-condition is there to say this is what a feature is supposed to do, and now this is my post-condition. Judge to see whether or not the post-condition is good enough. If you think it is good enough, give me an example how it works at the runtime. If you don't think it is good enough, give me a counter example where you might fail, right? Things like that. Yeah. There will be quite a bit of question like this in the exam. So yeah, but you got 3 hours. Yeah, so yeah, exactly. I'll just give an example. Yeah. Yeah. For example, let's say if I ask you about the very first one we talked about in the beginning of the session. If I go to, for example, let's say over here, let's say a linked list container, right? If I say I give you the post condition, let's say for the minimum, right? If you think all the 3 post conditions altogether are strong enough, then now give me one example to show that how it works, right? You will just give me one example over here. Right? On the other hand, if the post condition turned out to be not appropriate, of course your answer will be wrong, right? Yeah, you have to make sure you really justify properly. Right? Yeah, there will be quite a bit of writing, as I said in the last class, right? There will be no multiple choice. Actually, to be precise, there will be one multiple choice, one. Right? But that one is not going to help you too much. That one doesn't count too much. Yeah. That multiple choice there, basically after that multiple choice, you got to explain whatever your choice is. Yeah. Yeah, so, but you know. But I would say if you really go over the notes, go over the lectures recording, only part of it, the part you're not so sure about, it should be fine for the exam. Make sure your mind is clear, right? Yeah. Yes? So information hiding, you're hiding something, right, from the clients. So what do you want to hide? You want to hide the part of the system that's constantly under change, right? So you want to make sure, well, conceptually, you know what? You can, I'm going to explain that briefly over here, but you can also refer to the midterm review recording. I believe I said something about information hiding as well over there. Okay, that's very briefly. Basically, let's say if this is this supplier. Let's say this is supplier. Right? For the supplier, let's say this is your system, right? Part of it should be made public, part of it should be hidden, private, right? So somehow you want to make sure some part of your system that is very constantly under change, you want to make sure those parts are actually hidden, okay? If they're hidden, let me just use gray over here. If they're simply just hidden, that means the clients will have no access to them. On the other hand, the part that's kind of stable, for example, the interface, like a method signature for your system, or some feature that the client can always call. Okay, in that case, it will be the green part. That means conceptually, they can be just accessed by the clients. Okay, so what does that mean? That means let's say I have a client over here. Okay, the client is always referring to the green part over here, right? So that means if there's any change on the hidden part, the client will not be affected because that's already hidden from them. On the other hand, if there's any part that's changed on the green part, that's definitely going to affect them because their code already depends on the green part, right? That's kind of the example we talk about when we talk about iterator, right? So you really want to make that kind of decision to see which part to be hidden and which part to be revealed to the clients. Yeah. All right. Typically, one thing you want to hide is about a strategy for implementation, right? Let's say this. How do you implement a map? We know the map data type from 2011, right? A map is simply got key and value, right? So there are different ways you can implement a map. For example, you can use a hash table. You can use maybe 2 arrays. You can use a binary search tree. You can use a red black tree. I just name a few, right? So each one of them should not be of the concern of your clients. In that case, they should be hidden in the gray part over there. So now if you switch from binary search tree into a hash table, the client doesn't have to be bothered by that change, right? The bound diagram usually don't really show the hidden part. Typically, you don't show. So in the bound diagram, you only show the green part. Yes, typically. Yeah. So the bound diagram is mainly a communication to your clients. The client shouldn't be bothered by your implementation details. Right. Okay. Anything else? Are we good? Yes. Go ahead.
Subcontracting stuff, you mentioned how contracts shouldn't surprise it. Just to clear up, new preconditions shouldn't be any stronger.
Shouldn't be any stronger. It should require less.
Require less, and the new postconditions should not be weaker.
Should not be any weaker. That's correct. Correct. Yeah, I would suggest maybe go back to a subcontracting lecture. Remember I talked about the smartphone, iPhone 6s Plus. You can see the pre and post condition. I try to show it to you. Yeah. Okay, good. Guys, any more questions? The single choice principle, right? Well, to put it short, single choice principle simply means if there's any change on your system, it should be, you should really only have to modify the minimum number of places to make the change. One example could be, oh, actually, you know what? The state pattern that we just talked about, that could be one example. Okay, state pattern is really important. Okay, what I will do is I will try to go to here. Okay, now this is one example where the single choice principle can be violated, right? So now we talk about the design that comes before the state pattern, the hierarchical design. You can see for every feature over here, let's say display, re-answer, re-choice, correct, process, and message. They all take a state information, a state number, right, as part of the input, right? So that means for every one of them, you had to do some exhaustive check to see which state you're talking about. It can be state number 1, state number 2, or state number 3 for every feature. It's redundant, right? So now let's say if I add a new single states. So what should I do? If I add a single states, that means I gotta add an else if part, right? For every feature over here. I need to add an else if to display, else if to re-answer, else if to every one of them. That means for the new change, I gotta go to multiple places, right? That's one occasion for single choice principle. So in generally speaking, single choice principle means there should be only a single place where you do the change. Yeah. All right. Of course, there are other patterns which will also require the knowledge about single choice principle. You should really review them too. All right. No, you don't have to worry about the Java part. The Java part is mainly just to motivate you, right? To see why we want to teach you design using iPhone. Yeah. So the beginning Java code, I can even tell you the Java code for the event-driven design you don't have to worry about, right? But iPhone version you may have to study that, right? Yeah. All right, anything else? Are we good? All right, sounds good. Good luck. I'll see you on Sunday, right? Okay, see you then. Yep.